Hi there, in this video I'm going to do a past exam paper question on completing a square. So let's take a look at this question. Question number 3, x squared minus 8x minus 29, and that is equivalent to x plus a in brackets squared plus b, where a and b are constants. In part A to this problem, find the value of a and the value of b. So let's think about this problem. Let's get back to the paper and pen. So we have this quadratic x squared minus 8x minus 29, and in other words, for this particular part we need to complete the square. Now if you're unaware of completing a square, I have created a video explaining the process, and I'll provide a link to that video in the description below. Let me talk through the steps though. So for this problem, step number 1, we need to group in a bracket the x squared and the x term. So take the x squared term, take the x term and write them in a bracket. In step number 2, the idea is whatever is in front of x squared, so i.e. whatever the coefficient of x squared is, take that out as a common factor. So the coefficient of x squared here is plus 1, so we take plus 1 as a common factor, leaving us with x squared minus 8x within the brackets. So that is what step 2 is about. So let me repeat. Take out the coefficient of x squared as a common factor. So by doing that, this is what we have in this particular example. In step number 3, so pay attention to step number 3, copy the 1, copy these two terms, the x squared and minus 8x, so copy these three terms, and we always add, so we always add over here, and we're adding half of the number in front of x, so number in front of x is minus 8, half of minus 8 is minus 4, and you need to square that also. So let me repeat. So you need to look at the coefficient of x, or the number in front of x. So the number is minus 8. Half of minus 8 is minus 4, and we square that term. Copy the outer term, which is minus 29. Now in maths, you can't simply add something, you need to subtract something as well. So we're adding, think about it, we're adding 1 times minus 4 squared. So you need to subtract what you've added. So 100% subtract outside. So it's always add here, always subtract here. And what are we subtracting? We're subtracting the number times this term over here. So we're subtracting 1 times minus 4 squared in this case. So red with red, green means 100% plus here, 100% minus here. Now that takes us to step number 4, the next step. The next step is copy down the number that you have over here, so copy down the 1 in this case. Write down one of these x's, so write down 1x from here. Write down one of these minus 4's, close the bracket and square. So this is no trick, this is always the case that if you write down one of these x's, write down whatever term you have in this bracket, close this bracket here and square, and you can double check because it's always the case that when you multiply this out, you're going to get this term as a result. So we call this term a perfect square. Now what is left to be done is we need to simplify this term here. So we have minus 29, and minus 4 squared is plus 16. 16 times 1 is 16, with the minus is minus 16. And what we need to do next is we'll further simplify this outer term to give us 1. Let's copy down the x minus 4 squared, and minus 29 minus 16 is minus 45. So that should be the solution to part A. So if you go back to the question, we need to write that quadratic in the form x plus a squared plus b, and we need to state the value of a and the value of b. So if we go back to the paper and pen, so if we make a comparison with x plus a squared plus b, so by comparison, the a value is -4. So let's make a note, a -4. And as for b, b by comparison is -45. So b -45. So that completes part A. Now let's go back to the question because we have another part to do. In part B, hence or otherwise, show that the roots of x squared minus 8x minus 29 is equal to 0 are c plus or minus d root 5, where c and d are integers to be found. So let's see how this is done. Let's go back to the paper and pen. Now if you notice, in part A we had that quadratic, and using completing a square we wrote it in this form. We wrote it in the form x minus 4 squared minus 45. So let's rewrite this equation based on the solution of part A. So from the solution of part A, I can rewrite this as x minus 4 squared minus 45, which is equal to 0. So if we go back to the question quickly, all we need to do now is to find the roots of this quadratic, meaning we need to find the solutions to this quadratic. So if we go back to the paper and pen, let's rearrange for x. So first, let's take that minus 45 to the right to give us x minus 4 squared, and that is plus 45. To get rid of this square, let's take a square root on both sides. So if I taking a square root on both sides, and if you take a square root on both sides, for the left you're going to have x minus 4, but be careful, on the right hand side you're going to have plus or minus the root of 45. So not only you'll have a positive root of 45, you also have a negative root of 45. So let's rearrange for x. So taking the minus 4 to the right, x will therefore be 4 plus or minus the root of 45. Now we can simplify the root of 45 using our knowledge for surds. Root of 45 is the same as root of 9 times root of 5, and root of 9 is simply 3, so 3 root 5. So with that being said, I can write our solution as x is equal to 4 plus or minus 3 square root of 5. So if we go back to the question, so that is what we want, and that is what the question needs. We need to show that the roots of that quadratic are of the type c plus or minus d root 5, where c and d are integers. So if we go back to the paper and pen, so we have written our solution in that form. So in this case c, the c value is 4, as for d, the d value is 3. So c is equal to 4, d is equal to 3 in this case. And that completes part B. So that completes part B, and that also completes the entire question. So I hope you found this video helpful. I hope you enjoyed the video. If you did enjoy the video, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you again. Thank you.